Hey guys, today we're going to talk about the greatest common factor and the lowest common multiple. And for the video, we're going to refer to the greatest common factor as a GCF and the lowest common multiple as the LCM. So let's look at some vocabulary. And these terms are familiar to us. We've seen them, a few of them before. Prime number, as you remember, is a number with only two factors, that number and 1. A composite number is made up of more than two factors. And what we're going to be doing is breaking our composite numbers down to find the prime numbers that make them up. We then have the GCF, which is the largest factor that the numbers or the terms have in common, and we're going to be dividing with that. And then we have the LCM, or the lowest common multiple, and that's where we're going to be multiplying or skip counting. So let's look at an example. And so what we have here are, we're going to start off with 16 and 24. And you can see they're kind of in a layer. Okay, so we call this either a ladder or a birthday cake, whatever you prefer. And when we factor a number out, it has to go into both terms in that row. So this is kind of set up like we're dividing. Okay, so when we factor a 2 out of the 16, we're left with 8. So that remaining piece will go above the number we're working with. And so when we factor a 2 out of the 24, that's 12, so that goes above the 24. However, 8 and 12 are both composite numbers, so we can keep factoring. We factor a 2 out of the 8, we're left with 4. And we factor a 2 out of the 12, and we're left with 6. So 4 and 6, again, are our composite numbers. So we have to keep working. We can factor another 2 out, and 4 divided by 2 is 2, and 6 divided by 2 is 3. We're not going to do anything with these numbers at the very top just yet, the very top of the ladder, or the birthday cake just yet. For greatest common factor, we are concerned about the numbers on the side. And we're going to take those numbers, those 1, 2, 3 numbers, and we're going to multiply them together. So in this case, we're going to take 2 times 2 times 2, 2 times 2 times 2, which is 2 cubed. And we all know that 2 cubed is 8, so the greatest common factor for 16 and 24 is 8. A few more examples. We have 45 and 60, starting off down here. We're going to factor out a 5 out of both of these. So 5 goes into 45 9 times, 5 goes into 60 12. So 9 and 12 are both composite numbers. We're going to keep working. We know that there's a 3 that can be factored out of the 9, which will leave us with 3. We're going to factor a 3 out of the 12, and that will leave us with 4. And 3 and 4, there's nothing that can be factored out, so we're going to leave those alone right now. So we're going to take the 3 and the 5, bring those down, multiply those together, and we're going to get 15. So our greatest common factor for 45 and 60 is 15. And then for our third example, we have 42 and 39. So if we take 4 and 2, add those two numbers together, we get 6. 6 is divisible by 3, so we can factor a 3 out there. So 3 goes into 42 14 times. And if we take 3 and 9 and add those two numbers together, we get 12. 12 divided by 3 is 4, so we can factor a 3 out here. So 3 goes into 39 13 times. 14 and 13 don't have anything in common, so we're done here with 3. That's the greatest common factor for those two numbers. All right, let's look at some lowest common multiple examples. So LCM is going to have the same setup, but this time we're going to take into account the numbers on the top. So we're going to start off with 18 and 12 here. So we'll factor a 2 out of 18 and we'll be left with 9. And we'll factor a 2 out of 12 and we'll be left with 6. With 6 and 9 we can factor a 3 out. So 9 divided by 3 is 3. And 6 divided by 3 is 2. So now that we're at the very end here, all of these are prime factors, we're going to take the numbers on the side and the numbers on the top and multiply all those together. So if we take 2 times 3, which is 6, times 3, which is 18, times 2, which is 36, that is our lowest common multiple. And then for the numbers 9 and 45, we can factor a 3 out of the 9, and 9 divided by 3 is 3. And we can factor a 3 out of the 45. 45 divided by 3 is 15. And then when we have the line 3 and 15, we can still factor out a 3. So 3 divided by 3 is 1. 15 divided by 3 is 5. And we're going to take all those factors on the outside of the birthday cake and we're going to find the lowest common multiple. So we'll take 3 times 3, which is 9, times 1, which is 9, times 5, which is 45. So in this case, the lowest common multiple actually happened to be one of the numbers we were working with. Okay, let's let you guys get some practice. We're going to use 12 and 20 to find the greatest common factor up here, and then 12 and 20 to find the lowest common multiple on the bottom. Take a minute, pause the video, work through those, and we'll come back and check and see how you did. Okay, let's go over and see what we got here. So for our greatest common factor, we will factor a 2 out of 12 and be left with 6, and a 2 out of 20 and be left with 10. So with 6 and 10, there's a factor of 2 that's in common, so when we factor a 2 out, we're left with 3, and we factor a 2 out of the 10, we're left with 5. But for greatest common factor, remember, we're only dealing with the numbers on the side. So when we take 2 times 2, we're going to be left with 4, and that is our greatest common factor. For the lowest common multiple, again, we're going to factor a 2 out of the 12 and be left with 6, and factor a 2 out of the 20 and be left with 10. We will then factor a 2 out of the 6 and be left with 3, and factor a 2 out of the 10 and be left with 5. But for lowest common multiple, remember, we need all the numbers on the outside of the birthday cake here. So 2 times 2, which is 4, times 3, which is 12, times 5, which gives us 60. So 60 is the lowest common multiple. Okay, folks, that's it for this video. If you need to, again, feel free to rewatch the video. You can always go back and do that if you are unsure of the concepts, but we're going to be doing some practice in class, and I will see you there. Oh,